Hello, welcome back to LIVENODING. In this episode, we're gonna use animation nodes to do some kind of procedural animations. Basically, the idea is to start with something that's already organized or distributed, and then you kind of randomize it and or animate it like from like random positions back into the original like distributed position. So it's gonna be a little bit of improvisations, but let's just get started. So let's say you start with a bunch of cube. I'm gonna make it like so it looks like letter N. This can be any shapes, but I'll just start with this letter N for nodes. Can be AN for animation nodes, but anyway, so you got this bunch of objects and you want to kind of procedurally animate them. The first thing I will do is always to group it. Control G. Now they are like green color, and you can jump into animation nodes, and let's just get started. You can leave this always if you have good computer, like really fast one, or you can turn it off if you want to save a little bit of processing power. Okay, so we start with objects from group, and we grab our group, which is which contains all these boxes, and we just want to simply animate them. So object transform, you have two options using object transforms output or using the matrix output, object matrix output. So either way should work. So the idea is really from this position, arrange position, we want to kind of randomize it in all kind of directions. First of all, we need to tell animation nodes to keep the transformations because currently each object has the default positions, and if we simply just plug the objects and then make a new positions, they're all gonna go back to 0, 0, 0 position. So that's not a good thing. So you want to select all these objects, and then under this animation nodes tab, you want to get the initial transforms. Normally, you just need to select a bunch of objects and then click on this, and then all this initial position data is being stored. Okay, so what we want, if we want to access the data, we just need to use the object ID key. And here we just say, okay, we want the initial transform position. So these objects, now we are grabbing the initial positions, and we can use the matrix. Let's save this real quick and arrange to random. So we have this arrange position, and we have this output. We don't need this node for now. So this is the objects, and this is the initial position. You see how it's kind of jumping around, and now we are back into this arrange position. So that's a good thing. The next thing we want to do is simply to offset the matrices. So this is super basic, but I think very important concept. So you have this bunch of objects, you have these initial positions, initial transform, and you have this offset matrix. And here we can kind of push it, rotate it, and scale it in all kind of random fashion. Be careful with this button. If you click it accidentally, it's gonna disconnect the nodes. Okay, so we have these matrices. This is kind of, you can think of it like kind of a transform modifier. And with these translations, you can kind of, okay, push it in the X direction, for example, or in the Z directions, or in the Y directions. It doesn't matter. Let's try actually let's push it up in the Z direction. So it's kind of like off the camera. And let's try using delay fall off and plug in the time here into the time, and now we can see the objects kind of animate it one by one. That's what the delay falloff is for. Basically, it's gonna delay each object's position and kind of offset it one by one. So this is the default behavior. It's simply like push the objects one by one in the z-axis for 40 units, because it's just simply offsetting the matrix. You can also do you get the opposite, like if you switch from start to end. So now you get the opposite behavior. Now, if you, instead of just a translation, let's say, actually, I want to show you something with the X, for example. If we push it in the X, like 50 units, you can get this kind of effects, kind of like a off-camera offset, and then it looks really cool. It's kind of like zooming in. So that's now easy to do using animation nodes. You can also use random vector, because this is like a translation is X, Y, Z, and it's a vector is like 3 values. You can say, okay, 1, 2, 3, 4, 5, 6, 7. You can say generate a bunch of random numbers, random vectors, based on the number of objects. Get list length, get the total number of these objects, and plug this into the count. And now simply push the objects in all random directions. If we plug this into that guy, so now you can see that's random position and then arrange position, random arrange. Very cool, very cool effects, and we can do it so easily now. You can scale it, like let's say this is like a random star position, and it's kind of let's do the opposite. Random position and into arrange position, random arrange. So it's very basic, but I think I found this really cool effects. Even though it's so simple, you can also use the vector, random vector, for the rotations and for the scaling, if I'm not wrong. Actually, for the rotations, you need to use Euler, random Euler. Random Euler. How many objects? Click here. That's the total number of random Euler, and plug this in there. Now we have random objects at random position and random scaling. And then with time, it's gonna go into this position. Whenever you want to make like slight modifications to the original value, remember you need to store the informations. Let's say you want to, instead of having letter N, you want to change it to letter B, for example. By the way, the order also matter for the delay. Depends on how you sort the objects. The animation is gonna kind of animates in that order. So this is letter B now. Remember, you need to select all these objects and then get the initial position. And now you can have this randomly positioned objects, and then it's gonna transfer one by one to create our letter B. Let's give it some matcap and ambient occlusion to make it more interesting. So random position, one by one it goes to our position. So yeah, this is how this is very basic concepts, but I think really powerful, and this is how you want to kind of think of procedural animations. Probably not easy, but once you understand it, it's become so easy. And it's actually really complex. If you want to do it by hand, this can be really complex. Okay, you can do this by hand, but let's say if you have like 1,000 objects, how do you do that? You can use script or add-on, but you can do it using nodes as well. And if you don't like this randomness, you can always randomize the seed, get different look, and then you can always get the same result like that. This is probably a little bit too random, too big of a scale. Maybe we want to, I'm not sure if we can plug in a multiple value into the scale. Maybe we can. Okay, let's try vector math, vector list math, and maybe we can scale this, or we can average it. That's kind of interesting, not too interesting. It doesn't have the scaling. Maybe we need 2 of this. Like that. Slightly better. Still not random enough to my liking. It's kind of okay. So yeah, that's pretty much it for this live noding. I guess you can always try, you know, make your own new arrangement. Let's try this BS for Blender Sushi, and then select all these, get initial position, and then now we have new animations. And this is just simply using the delay fall off, but try also all kind of other fall off. Wiggle, interpolations, mix the fall off, or even like the directional fall off and all other fall off, and you get different kind of animations very, very easily. But this is pretty complex, you know. It's pretty amazing that you can actually do this so easily now. So I wonder if we can plug in a multiple value here as well, maybe. Random number. How many objects we need? Plug this guy in. Plug that guy in there. Oh. Yeah, I think apparently you can do that as well, which is pretty cool. Actually, no. You can see it gives like a random number, but it doesn't work. Doesn't work with this guy. I might be wrong, but yeah, I think it's not factorized. You see, it's not being pushed in the different scaling. It's only picking a one value. So anyways, this is still a pretty cool procedural animations. And yeah, so that's pretty much it. Thanks again for tuning in, and I'll see you in the next video. Thank you. Bye.